Hello, everybody. So we are continuing talking about the quadratic formula, and something specific about it is what's called the discriminant. And the discriminant is b squared minus 4ac. So it is the number inside the square root. It is not the square root of that number. It's the number inside the square root. But you need to know what that tells us. And it tells us a very, very simple thing. So this is going to be a simple lesson, but please still pay attention. What does that discriminant tell us? And the quadratic formula, realize, only works when the quadratic equals 0. So the quadratic formula is always finding the zeros of some particular quadratic. So the discriminant is going to tell us something about the zeros. Let's begin. Well, here I've got a quadratic, and there's no mystery what the zeros are. I can see them. One of the zeros is 0.209. The other one is 4.791. And here is the function that generates this parabola. But let's use the quadratic formula and see what we can see. A is -1, B is 5, C is -1. You should really pause the video and calculate the quadratic formula correctly. You need to be able to do this 20 times out of 20 correctly. So you plug in all the numbers for A, B, and C. And notice B is 5, so B squared, I just put 25 right there. And then at this point, this is what I recommend you doing, is you just do everything all at once. So for example, 25, watch what I do. 25 minus 4, parentheses, -1, parentheses, -1. So I let the calculator do all the work. This is the discriminant, b squared minus 4 times a times c. Press enter, 21. So I never make mistakes. I just let the calculator do all the work. 21 is the discriminant. 21 is the discriminant, not rad 21. 21. And the square root of 21 is 4.583. So how do I find my two answers? I take -5 plus 4.583, that equals this number, and I divide that by -2, and I get 0.209, one of my zeros. And then I take -5 minus 4.853, and I divide that answer by -2, and I get the other zero, 4.791. Okay, so what have we learned about the discriminant? Not much. We'll learn more in a second example, but the discriminant was 21, and that got me these two zeros. All right, example 2. Okay, this one's different. Look at the zero. There's only one zero. This one only has one zero. So I wonder what the discriminant is going to be. All right, this one over here, when the discriminant is 21, there were two zeros. And now in this example, there's only one zero. Let's determine what that is. So A is 4, B is 12, C is 9. Plug it into the quadratic formula. You should pause the video and figure it out. But you type in everything. B is 12, so 12 squared is 144. Go into my calculator, 144 minus 4, parentheses, 4, parentheses, 9. Enter. When I get 0. So the discriminant is 0? Yes. And what's the square root of 0? 0. What's -12 plus 0? It's -12. And -12 divided by 8 is -1.5. There's nothing under here. This is a red herring. Okay, so let's sum up what I have. When the discriminant was 21, I had two zeros. When the discriminant was 0, I only had 1. Now, in this third example, how many zeros do I have? Well, I have no x-intercepts. This parabola is not hitting the x-intercept at all, at the x-axis at all. So that makes me very curious of what the discriminant will be, because I know if the parabola hits it twice, for this example at least it was 21, if the parabola hits it only once, the discriminant was 0. Now it's not hitting it at all. What is the discriminant? Well, A is 1, B is -3, C is 4. So I plug in all the numbers. Since B is -3, this is -3. So this will turn into +3. And if you square -3, you always get a positive. so positive 9. And I go back, 9 minus 4 times 1 times 4, negative 7. So the discriminant is negative 7. Now, my friends, what is the square root of negative 7? It is I rad 7. It is imaginary. The square root of a negative number is imaginary. And rad 7 is about 2.646. So since it's I times rad 7, I can write it as 2.646 times I. And now I need to find my two answers. Well, that's a problem because I can't take 3 plus 2.646i. They're not like terms. This is an imaginary number. This is a real number. So I'm stuck. I can't really continue. So my best answer is this answer right here. Well, what is the conclusion? What is your guess about discriminant? What did discriminant tell you? The discriminant is b squared minus 4ac. We saw 3 examples. We saw one example where the discriminant was positive. It was positive 21. One when it was negative 7. And one when it equaled exactly 0. Well, when the discriminant is positive, there are 2 x-intercepts. That's the same thing as 2 real zeros. And that's the same thing as 2 real roots. All 3 of these sentences are identical, and we have to be comfortable with going back and forth between all 3. Roots and zeros are the same things, and if the 0 is real, then it's an x-intercept. And since there are 2 real zeros, there are 2 x-intercepts. The last problem we did, this discriminant was negative 7, and there were no x-intercepts, right? So there are no x-intercepts, but there are zeros and roots. They are imaginary. So if we have imaginary zeros, there are no x-intercepts. And we still call it 0 because this is a number. It's actually 2 numbers, and they're both imaginary. If I take this number as x and plug it into here, I'll get 0. So it still produces the number 0. It just is not visible on this plane because this plane represents real numbers only, and this is an imaginary number. And finally, what's your conclusion? What's underneath this purple box when the discriminant is exactly 0? That means that there's 1 x-intercept, which means there's only 1 real 0 and only 1 real root. We don't really have a situation where we have 1 real root and 1 imaginary root. Imaginary roots come in pairs, definitely for our class. That's almost everything we do. Yeah, everything we do in this class for sure. If there's an imaginary number, it's going to come in pairs. So there's no case where you're going to have 1 x-intercept only and then 1 imaginary. I mean, think about this quadratic here. I'll give you an A for the whole year if you can draw a parabola that has 1 x-intercept and 1 imaginary solution. So 1 real answer and 1 imaginary. If you try to drag this parabola up and down, you either get 2, you get exactly 1, or you get exactly 0. You can't have 1 real and 1 imaginary. All right, and then rapid fire, just really quick, looking at these. This parabola right here, since it has 2 real zeros, I know the discriminant is greater than 0. Here, this parabola doesn't have any x-intercepts, so the discriminant must be negative. Here, I got 2 x-intercepts. Discriminant must be positive. Here, I physically don't see it touching the x-axis, but I know it'll eventually get down to the x-axis. So it has 2 x-intercepts. Discriminant is positive. Here, it'll never hit that x-axis. It tries, it goes way up here, but it doesn't hit the x-axis. So there are no x-intercepts. So that means the discriminant is negative. And here, there's exactly 1 x-intercept. So the discriminant is 0. There is homework on Delta Math regarding this. And remember, your midterm is tomorrow. Good luck, everybody.